Hello friends, let us see some preliminaries to find summation of series. We find sum of first n natural numbers, sum of n terms of arithmetic series, sum of n terms of geometric series. These are very useful in finding summation of general series. First, let us find sum of first n natural numbers. Let Sn be the sum of the series. Now, reverse the terms of the series. Write the last term in the first and reverse all the terms and bring the first term to the last. Add these two series vertically term by term. In the left hand side we get twice Sn, and in the right hand side we see that sum of each term is n plus 1 and there are n such terms. Therefore, in the right hand side the sum is n times n plus 1. Therefore, Sn is n times n plus 1 divided by 2. This is the sum of first n natural numbers. Now we find sum of n terms of arithmetic series. The first term is a, the second term is a plus d, the third term is a plus 2d, etc. and the nth term is a plus n minus 1 into d. Let Sn be the sum of the series. We observe that the difference between second term and the first term is d. The difference between third term and the second term is d, etc. The difference between nth term and the n minus 1th term is also d. So in this series, the difference between any two successive terms is a constant and is equal to d. Such a series is called as arithmetic series. So this is an arithmetic series with n terms. To find the sum, we add the series Sn and we reverse the terms as before. So write the last term to the first one and reverse all the terms. Now add these two series term by term. So in the left hand side we get twice Sn. In the right hand side, sum of each term is 2a plus n minus 1 into d. And there are n such terms. Therefore, the sum is n times 2a plus n minus 1 into d. Therefore, Sn is equal to n by 2 into 2a plus n minus 1 into d. This is the sum of n terms of arithmetic series. Finally, we find sum of n terms of geometric series. The first term is a, second term is ar, third term is ar square, etc. And the nth term is ar power n minus 1. Let Sn be the sum of the series. We observe that the ratio between second term and the first term, that is ar divided by a, is r. The ratio between third term and the second term is r, etc. The ratio between nth term and the n minus 1th term is r. So in this series, the ratio between any two successive terms is a constant. And such a series is geometric series. And this is a geometric series with n terms. To find the sum, we write Sn and take it as equation 1. Multiply each term of Sn by r and take this as equation 2. Now subtract equation 2 from 1. In the left hand side we get Sn minus r into Sn. In the right hand side, except the terms a and ar power n, all other terms gets cancelled. Therefore, in the right hand side, we get a minus ar power n. Therefore, Sn is equal to a into 1 minus r power n divided by 1 minus r. This is the sum of n terms of geometric series. If modulus of r is less than 1, then the values of r power n decreases as n increases. For example, if we take r is equal to 0.25, then the value of r square is 0.0625, which is less than r. The value of r cube is 0.015625, which is less than that of r and r square. So, if n increases, then the value of r power n decreases. So, if modulus of r is less than 1 and n is infinite, then r power n will become 0. Substituting the value of r power n in our formula, we get the sum of infinite geometric series is a by 1 minus r. If we take a is equal to 1, then the series becomes 1 plus r square plus etc., whose sum is 1 by 1 minus r. So, sum of this series is 1 minus r power minus 1. We know that this can be expanded using binomial theorem also. Thus, we found the sum of first n natural numbers is n times n plus 1 by 2. Sum of n terms of an arithmetic series is n by 2 into 2a plus n minus 1 into d. Sum of n terms of a geometric series is a into 1 minus r power n divided by 1 minus r. Thank you for listening.